Okay, 6.1, day 2. Today we'll be working on calculating and interpreting the standard deviation of these discrete random variables that we started on day 1. And then we'll also be using the normal distribution actually for these continuous random variables. Okay. All right, let's recap where we were, or where we left off day 1. And that was going over the expected value. Okay. So we had this example that was relating these randomly selected hockey teams. Okay. Here's the distribution of goals from 0 to 9, and then we calculated the average number of goals to be 2.851. Okay. All right, so we're going to move on to standard deviation using that same example. Okay, we know standard deviation means typical number of the typical distance basically from the mean. So if our mean is 2.851, when we randomly select the hockey team, we know sometimes we'll get 3 goals or 0 goals or 1 goal. What is that typical distance from 2.851? Okay. All right. Now the standard deviation, there's a little workaround on the standard deviation. We have to find the variance first. Okay. And this formula, which is given right here, was also given on your yellow packet. So the variance of a random variable x is equal to standard deviation squared. And here it is. It's the sum of the difference of each individual x minus the mean. We square that number and multiply it by the probability. It's a pretty big process because you have to do that for each individual x value. There is a shortcut, but let me show you how we start the work to start, and then we go to the shortcut. Okay, so here we go. The table below gives the probability. Okay, so we've seen this before. Here's the formula. You may want to pause and write that down if you want. Okay. All right, so compute and interpret the standard deviation. So here we go. Here's the workaround, right? To get the standard deviation, we got to find the variance first. You got to make sure you understand that difference because you don't want to get the variance and then report that. You need to report the standard deviation. All right, so we take this one at a time. So I'm going to grab my individual x value of 0, subtract the mean, which we computed before, and then we square that difference. And then you multiply that by the probability of that. Okay, pretty easy to follow once you have the formula and you understand the process. Let's do it one more time and then we'll skip to the last one. So plus 1 minus the mean quantity squared times the probability of that event. Okay, everybody see where I'm getting this from? All right, now that's a lot. So here we can kind of shortcut it, and that's the AP expectation too. They just want you to get it going. Okay. Plus dot, dot, dot. Let's finish with the last one. 9 minus the mean squared times the probability. Okay. All right. And let me show you how we get this. The answer is 2.66, but I'll show you how we get that. I still have this distribution loaded in my calculator from day 1. So if I go in there, there it is. There's the distribution. We still go to stat, calculate, and we do one variable statistics. Okay. All right, and here we go. This reports the standard deviation. So I'm going to have to kind of jot that down off to the side for now. I do not want to write 1.63 here. That's a big mistake, and it's a common mistake. Okay, so standard deviation, I just reported over here. It's 1.63. Okay, but square that. So go to your clear screen and square it, and we get 2.66 for the variance. That's what you need to write here. Okay, so if they ask you to compute this on the AP exam or your own Chapter 6 test, show this, make sure you put the right number here, and then it says to interpret this. All right, so a randomly selected hockey game will typically differ from the mean by about 1.63 goals. Okay. All right, pause and write down that interpretation because I'm going to keep going here. Okay, you really have all the skills to try 7 as well. So I want you to read through 7, compute and interpret the mean, which we did on day 1, and then compute and interpret the standard deviation for this. All right, pause and try it now. Okay, here's your feedback for the mean. Here's the work you can show. I mean, you don't really need to shortcut it. There's only 4 components anyways. So here it is. We get 1.1. All right, and then usually the authors want you to use some type of long run interpretation. So you can say in the long run or after selecting many Fridays, we'd expect the average number of cars sold to be about 1.1, and this is only for the first hour. It's not all day, right? It's not all hours, just the first hour. Okay, so you can see how this was actually a check your understanding of the book. You can see how they did the same thing. Okay, many Fridays are selected. And here's number 2. I'll show you the work here in just a moment, but you should have got 0.943 for your standard deviation. So the number of cars sold on a randomly selected Friday is going to typically vary from the mean by 0.943 cars. And here's the work. Once again, I don't really know if you need to shortcut it much, but if you did, fine, as long as you showed some of the work. There it is. Okay. Okay, I'm going to pause here to get ready for the next page. Okay, this last page deals with continuous random variables. Remember, discrete are the numbers with gaps in them, shoe sizes, number of goals scored, right? Continuous, though, has a lot of decimals in between, multiple numbers, okay? So height is an example of a continuous random variable. All right, this is actually 100% review. If example A is going to confuse you, you need to go back and revisit section 2.2. Okay. All right, so let's take a look what they're asking us to do. It does say that the height follows a normal distribution. Okay, sometimes we can use the empirical rule if the numbers work out good, the 68, 95, 99.7 rule. Typically, though they don't, we'll have to use table A and normal CDF. Find the probability that the chosen woman is between 68 and 70 inches tall. Okay, remember there's a 3-step process to this. So you got to draw in and shade the normal curve, the areas of interest, and also name the distribution. Okay, so step 1 over here. State and sketch. I'm going to kind of go quick because I know, again, you have the ability to pause. All right, so state and sketch. So that's normal. There's the mean. There's the standard deviation. Okay, so then I started adding 2.7 to the first inflection point, then kept the scale the same. Remember, that's how we kind of do this. Approximate inflection point for your first standard deviation, then keep the scale the same. So 68 falls somewhere around here, 70 falls somewhere around here. Step 1 is done. Okay, now how do we find the area under the curve? Okay. So by hand, we can find the z-score. Remember, z-score is x minus mean over the standard deviation. All right, which is kind of in words on your yellow sheet as well. Standardized test statistic, z-score, is the statistic minus the parameter or mean over the standard deviation. Okay. All right, so I get 1.48 for that first z-score. I get 2.22 for the next one. So then we can use table A to get those corresponding areas. All right, so the area all the way over to the z-score of 2.22 is almost 98.68%. And then this is 93%. So we subtract those to get the shaded area. It comes out to be 0.0562. Okay, or you could use the tech steps, normal CDF. You put the lower bound, upper bound. You got to write all this out and label it correctly. Okay, or maybe use the z-scores. You could put the z-scores in here, and then you put a 0 here and 1 here. All right, so step 3 is to answer the problem. What did we just find? There is about a 5.6% chance of randomly selecting a woman who is 68 to 70 inches tall. All right, so really just put a probability spin on this. In section 2.2, they said, here's the data and what proportion are between 68 and 70. We just said, here's the population between 68 and 70. Now they just kind of said, what's the probability of randomly selecting somebody between 68 and 70? All right, the process is still going to be the same. Okay, I added a part B just because we should review this. What heights would represent the 90th percentile? Okay, so if they asked you for a question like this, or what's the probability of randomly selecting somebody at the 90th percentile? Here's what we do. Area under the curve is 0.90. Okay, so we can find the x value this way by plugging in the z-score. How would I get that? You can use table A or you can use inverse norm. 0.901 gives me z-score of 1.28. Okay, and then this stuff was given, and then solve that. Okay, you could also jump right to inverse norm, do area 0.9, put in the mean of 68 4, and then put in the standard deviation, 2.7. Okay. Once again, another problem we reviewed in section 2.2. Okay. All right, that's it for section 6.1. We're also going to start 6.2. We are going to quiz this week on 6.1 and 6.2 to wrap things up. Okay, so when you get here, we just covered these two, but I'm going to have you guys do a lot of this on your own, the first part, because it's a lot of review as well about the effects of transforming a random variable, by adding or subtracting a constant, and multiplying or dividing. We went over this once in chapter 2 as well. All right, so here's what I expect you to do for that. Hold on, let me find the notes. All right, so like I said, you're going to do this part, and then Wednesday we'll have these to wrap up, and I'll kind of give you some review heading into our 6.1, 6.2 quiz, which would be Friday, okay? All right, so you're going to do the first page of this, okay? Now I'll scroll down, and you can pause it if you want, but I encourage you to definitely read for understanding. And we went over these transformations on 94 and 95. So that's what I did first, the first part of our notes. I reviewed, we did a height lab. We talked about the guys walking in with heels on, or the whole class with heels on, and increased their height. You may remember that lab. That's where we got these conclusions from. Okay, so review, fill in. All right, then you're going to start reading 6.2. And as you're reading through 6.2, you're going to be filling in this information right here. Okay, example 1 is in the book. This is the exact one in there. So you can read and fill this in on your own. Okay, and then the same thing with the next page. Example 2 is in your book. So you're going to look at these rules. You're going to fill in example 2. And then example 3 is to check your understanding in there. So then try that as well, all the way through. Okay, so I expect you to take pictures of this too and turn this in as part of your assignment. All right, have a good day.